Hello everybody and welcome. My name is Samer Audi, and in this video I will demonstrate how to create a simple virus. This video relates directly to the malware lab activity in CIS2103. Let's start with the setup of this activity. The first stage of the virus lifecycle is the design phase, which involves developing the virus. We will be doing this in Kali Linux. The second stage is replication, and this is when the virus gets spread and infects unsuspecting targets. We will of course do all of this in a controlled environment, and therefore we will use our Kali Linux and our Windows XP that are available on the course machine. Okay, let's start. As the virus creators, we will be working only from Kali Linux. Windows XP comes later for testing, and we will need three tools: Metasploit framework, MSF Venom, and Apache web server to spread the virus. The good news is that all these tools are already pre-installed and available in Kali Linux. You don't need to do any installation or configuration or setup. Before I start creating the virus, I want to talk a little bit about Metasploit because it is a very powerful security framework, and if you major in cybersecurity, you will see more of it. Metasploit has modules within it, but also it has standalone components that you can use separately. One of these components is MSF Venom. Within MSF Venom, there is a payload module. A payload is a term that we use in security, but also in military and other areas as well. It is simply the active element that does the work. So in a missile, for instance, the payload is the destructive element that explodes. In a virus, it is the element that does the nasty work. Now we're ready to create the virus. We first need the IP address of our Kali, and you should know how to get it at this point. We can use ifconfig, but I prefer IPA. And this is my IP address, 172. I'm gonna just use this notepad to put some notes, including the commands that I will use. Next, I will type MSF Venom without any option, just to invoke the help system. Notice some of the options that are available. We will use some of those shortly. The first option we will use is the P option, which is to include a payload. At this point, an experienced security person or a hacker would know tons of payloads, or they can even create their own payload. Since this is your first security course, I will select a good payload for our lab. What this payload does, it establishes a connection with the victim's machine. But how will I know that someone opened my virus? Well, my computer needs to be up and listening to any incoming connection. So I need to include my own IP address to complete the connection. So we need another option to include our IP address, and that option is the L host or the local host. This is my Kali's IP address. Please make sure you use your own. Incoming and outgoing network traffic in our computers go through logical openings. We call them ports. Imagine if your house is the computer. Anything coming in or going out must enter or leave through a door or even a window. This is what a port does. Each computer has 65,536 ports potentially available for connections. Without going into too much details, let us choose one of those and dedicate it for the connection from the victim's computer. So I will need another option, and this time it's the L port or the local port. 443 is the HTTPS port, which is basically the secure web traffic port. Next, we need to specify the file type of the virus. Remember, our virus, like most malware, is simply a file. So let's add another option to the command, this time the F option. This says that our virus is an executable or a runnable application. Next, we need to specify the full name of the virus, including the extension. Let's call our virus calculator.exe, and for that we will use the O option. So now we have our full command to create the virus with the payload that we chose. Okay, so now we are ready to create the virus, so I will run the command. And there it is. You can see saved as calculator.exe. So let's find the file. And there it is. My calculator virus is created. Next step is to start the Apache web server and put it there, hoping for some unsuspecting victims to download it. One way to distribute a virus is as a downloadable file on a website, and then we can send phishing email to thousands of potential victims. Anyone who lacks awareness, and definitely not a security student, might fall for this trick and download the file. Kali has a web server ready for use. It's called Apache. So we will go ahead and start the Apache web server using the following command. What I want you to do at this point is to learn more about this server. And what better way than the help system or the man pages. So go ahead and pause the video and explore the options for this new tool. There will be questions about it in the lab and perhaps even in the exam. Now that the web server is up and running, we should be able to access it via a web browser and using the IP address of Kali. So let us test it. I had to restart my Kali, and therefore just a quick note, always check your IP address when you restart your virtual machine. The reason is the virtual DHCP server might give it another IP address, and in my case it did. So as you can see here, this is my IP address, so I'm gonna update it. And I will go ahead and test it from my main cloud machine. And there it is. That is the Apache homepage. My web server is up and running. Next is to move the calculator virus into a folder on the web server. So let's do that. To access the directory that has the web pages of the Apache web servers, you go to var www and then HTML. Here you can see the index page. I'm not gonna go into the details of web pages and web servers, but index is the default name in Apache for the home page. So this is the page that we were able to see in Google Chrome. What I want to do at this point is to create a subfolder and call it downloads and then put the calculator file in it. Okay, so now we have the virus in the download subfolder, but how do we access it on a website? Simple. For a subfolder, you simply add in the URL a slash. So let's go to Chrome again. Slash. And there it is. But of course, I'm not gonna click it here because this is my main machine and I know it's a virus. Instead, later I will access it from Windows XP. So now my virus can spread via this web. Anyone who clicks this will be infected. But before we test it, remember what the virus does. It creates a TCP connection back to my Kali. And I need a way to capture this. So we need one more step. In Kali, I will create a listener or a handler that will capture this incoming connection from the victim's computer. To do that, I will use the Metasploit framework. So let's start it by using the msf console command. Now that Metasploit is running, I will use the handler, which is available for multiple platforms within the exploit module of Metasploit. Notice how I will type it. If you make a mistake, you can simply type back and then retype it. Okay, now we have a handler. Next is to set the payload that this handler will handle. and the payload is set. Like I did before, I need to give the handler additional information, so I need to set some parameters. First, which machine will listen, meaning I need an IP address. And in this case, it's my Kali. And then, which port. We can double check these parameters by using the show options command. As you can see, the local host is correct, the local port is correct. In case you made a mistake, you can set them again in the same way. The final step from our side as the virus creators is simply to run this exploit. And for that, we can use the run or exploit command. Run is easier. Let's recap the virus development process. First of all, we used MSF Venom to create the virus, which is a file, an executable file, and we have in it our payload, which is the reverse TCP Meterpreter payload for Windows. What we're doing in this virus is to create a connection back to a certain machine, in this case our Kali Linux, and this connection will go to port 443. And that's the command that you see in front of you. Next, we started our Apache web server and then copied the virus on it. This is our way to distribute the virus. We can use phishing email and other attack vectors to get people to download and run the virus. In the third and final step, we use the Metasploit framework to create a handler that will listen to incoming connection from victims' machines. So now our command center is up and running, our handler is listening, all we have to do is sit and wait. Okay, I restarted my machine and the IP address changed one more time. If this happens to you, please make sure you recreate the virus because it has the IP address of Kali. Let's be the victims on Windows XP and let's download and run the virus. As most people would do, we will ignore the warning. But what I want you to notice is what will happen on Kali as I run it. The handler is immediately invoked and Meterpreter, which is the payload available in Metasploit, is now running. What this basically means is that now there is an open connection between my Kali and the victim's machine. So basically the victim's computer is now hacked. As a simple example, I will take a screenshot of the victim's machine from Kali. As you can see, the screenshot is saved in the root folder, so let's go find it. And here it is, a screenshot of the victim's machine. What else can we do at this point? Well, use your imagination and of course your skills. Let me show you one more thing. I will use the shell command available in Meterpreter to gain command prompt access to the victim's computer. This would allow you to use pretty much any Windows command to do whatever you want. Create new users, change passwords, disable the firewall, shut down the machine, or better yet, turn the computer into a zombie machine to be part of the hacker's botnet, which would have tens of other victims' machines. This is it for this video. Of course, we can make the virus more sophisticated, more difficult to detect. We can even turn it into a Trojan, but this is beyond the scope of the course and we will leave it for another video. Thank you for watching.